Let me start by saying that a student found an error in lab 3. And the error is that in the pseudocode, less than 2 should read less than 4. So the condition was overly restrictive, and so collisions were missing. That should be 4 because that's 2 radii. And that's the basic collision condition. So there was an error. It is now fixed in the pseudocode. And thanks to rain. So any questions on lab 2 or 3 at this point? Let me state again, with regard to lab 2, that it's a really good idea to read the Protothreads page, because there are a couple of versions of Protothreads, and the one you want to be using, if you do a thread operation from within a case statement, is Protothreads 1.2. 1.1 was broken as designed, and 1.2 uses a GCC trick to make thread operations within a case statement work correctly. So for lab 1, it didn't make any difference. Nobody tried to launch a thread from within a case statement. In lab 2, a lot of people are doing that. It is really essential to use 1.2. The reason that some of the examples are still in 1.1 is that it depends where in last year that I recoded 1.1 to 1.2, whether the examples are in which kernel is used for the examples. And sooner or later I'll update them all to 1.2.1, but they're not there yet. Any questions on that? Next thing is, there's new lab hours routinely now. I put it on the schedule. Well, let's see. Yes. So routinely, the lab is going to be open Monday and Tuesday morning from 9 to noon on Monday and 9 to 1300 on Tuesday. And so you don't need to request those times. It'll just be open. The exception is fall break, where the request was that not open on Tuesday until 10 a.m. because they said nobody would. People thought they wouldn't show up at 9 because they'd be sleeping. So fall break, the lab will be open Tuesday 10 to 4 or 4:30. Any questions? So I wanted to do a couple of things today. I want to talk a little bit about plagiarism, and I want to talk not about you taking people's work, but rather people taking your work. And I wanted to talk a little bit about pins and special functions, because PB4 and PB5, port B4 and B5, have some special functions that were messing people up when they tried to use them for chip selects. And so I thought I'd talk about resources that are available for figuring out what in the heck pins do. And the resource a lot of people have been using is this, if I can click on it. But this is a simplified version for quick reference. The full version of all of the pin functions is in Lab 1. And we can get it at the PDIP pinout, which I thoughtfully copied from the data sheet. And you can see that B5, pin 14, has at least 2 other functions that aren't registered on the simplified version. And one of them in particular, GED3, gets in the way of it being a chip select line unless you disable a debug function. B4 has some other function here, which it turns out is related to JTAG debugging. And so JTAG debugging has to be turned off. So when in doubt about the functions of pins, don't use the simplified version, the quick lookup simplified version. Use the full pinout. And also, every signal that this machine can produce, I put in a, again, abstracted from the data sheet, put in a chart with our pinout highlighted in a tasteful minty green. And so you can scan this. It's by signal name in no particular order. It's approximately alpha order, but not exactly. However, there's only 6 pages of it, so you can scan for pins. So you can say, what functions are on pin 14? Nothing here on pin 14, which some people are having trouble with. A bunch of PPS stuff. Okay, all clean. Let's go to page 2. Oh, there's a 14. What is that? Oh, B5. That's safe. That's a signal pin. So we scan down. Oh, 15. RB6. Port B6 should be on pin 15, except that note 2 says that's on the MX1 devices only, and we're using MX2, so there is no port B6 on our device. Well, that's annoying, but okay. So then we go to the next sheet and we find nothing on pin 14. I know there's at least one more. Ah, pin 14. That's the TMS. What's TMS? JTAG test mode select pin. Okay. Pin 4. Oh, there's a note, pin of number 3. So let's go down and look at 3. Oh, it's on the 22MX2 series. We care about that. You've got to disable JTAG, or that doesn't. You can't use that as an I/O pin. And so these tables, as the semester goes on, and you're going to be using more and more pins for more and more things, you're going to need to look at this signal list here in some detail. Also, the pin select, the PPS tables, which were abstracted, thoughtfully abstracted by the student, are incomplete. They have only the most used signals. the ones that you're likely to run across in labs 1 through 4. The complete list is here. So when you need to learn how to set up a T3 clock input, you're going to go to this table. So use these local tables here from lab 1 to make sure you know obsessively which pins are used for which functions. You try and toggle a pin, it doesn't work. Try and find out why by looking at this table. I did one further modification. That reminds me, I did one further modification to the Protothreads stuff this morning, and that is in config.h. The newest version of config.h has debug turned off. It turns out that debug affects RB4 and RB5. So I added that. The documentation for lab 2 tells you to add it, but I decided I shouldn't just leave it with the document, the optional documentation, but just should hard code it in. So that's now hard coded in to the version 1.2 config.h. The last thing, somebody asked, how do you change the CPU frequency? And that's going to be important for lab 3 because you're going for maximum performance. And so you might think that if you up the clock rate of the CPU, you'd get more performance, and you will be right within a limit. And the limit is you can't arbitrarily increase the SPI speed. And the SPI speed will become rate limiting for when you're drawing lots of balls on the screen. But with that caveat, let's talk about the phase lock loop that determines the frequency of operation of the CPU. Do you all know how a phase lock loop works? You know what a phase lock loop is? Is this covered in digital logic in 2300? No. Okay. So a phase lock loop has a phase detector. Oh, let's not write that out quite so big. Let's just call this a phase detector. And the basic operation is that there's going to be an output square wave that is fed back into here and compared in phase to a input F reference frequency. So if you phase lock these two, then this output will be at constant phase relationship to F ref in, so they will be at the same frequency. The modification, the generalized form of this, is that you have a phase detector, you have an input divider. This is a frequency divider now. So you have F ref coming in. You frequency divide it. You have a frequency divider here. And you have a frequency divider here. So if you divide the frequency that you're feeding back, then to have a constant phase relationship between this signal and this signal, this frequency must be higher. So if you have an N divider here, then the frequency here will be N times F in, where F in is this. So if we go to the config.h file, We see a bunch of really obscure acronyms here, but what we're going to be looking at first is that the oscillator is going to be set to the RC oscillator, internal RC oscillator phase lock loop. So this is going to be the internal oscillator, which doesn't show in config.h, but this is set to 8 megahertz with what accuracy? You should all know by now. 0.9%. Plus or minus 0.9%. And you can trim that. You can make it exact if you care enough. You could trim that frequency using a trim register. But let's just call it 8 megahertz. It turns out that on this chip, the input to the phase lock loop must be, Fin must be greater than or equal to 4 and less than or equal to 5 megahertz. Don't know why, that's the spec. Therefore, you have to set the input divider to divide by 2. If you look at the config here, it says phase lock loop input divider is divide by 2. If you change that to any other value, it won't work. I tried it. It really truly doesn't work. So this frequency is 4 megahertz. Now what I've done here in this code is to set the phase lock loop multiplier to 20. So n is equal to 20. So the frequency coming out of here is 20 times the frequency coming in. So for an 8 megahertz signal divided by 2 times 20, the output here would be then, if n is 20, the output here would be 80 megahertz. That's above the maximum operating frequency for this chip. This chip is rated at 50 megahertz. You can actually look at that on the chip itself. It gives the part number, and then there's a P50 afterwards, which is 50 megahertz. So what we then need to do is to divide the output. The phase lock loop output divider is set to divide by 2. So we divide this by 2 again, and we get 40 megahertz here. Then the peripheral bus clock comes off of here with an optional divider. In this case, the peripheral bus divider is set to 1. So for the default config file, then the peripheral bus is running at 40 megahertz, and I think that's what you all use to time to set the timers in lab 2, 1 and 2. Nothing cast in stone about this. How close to 50 megahertz can you get? Partly how close you can get depends on the range you're allowed to set here. And I can't remember how high it goes, but I think it goes at least to 22. If it went to 25, then you could multiply by 25 and get 100, and then divide by 2 and get 50. So who has an open laptop who wants to look that up? in PLIB. Another possibility is that you set, let's say, now the next question is, can you overclock this thing? How much can you overclock it before the top blows off of it or something else happens? The answer is you can overclock it, and it depends on the chip. They all run at 50. Many of them will run at 65. None of them will run at 80. Some will run at 72 megahertz. So let's say you wanted to set this up for 60. What could you do? How would you set this? How would you set the dividers? How would you set that divider? And this one. This one has to be 2. So you can't change that. But you can change this and you can change that. So what combination gives you 60? 4, that's 4 megahertz there, times 30 is 120. If you can set this to 30, and I'm sure you cannot. So what are the other possibilities? 15 and 1. So you could set this to 15 and this to 1, and now the output would be 60 megahertz. Yes?
The PLL multiplier goes up to 24.
Up to 24. So if you, thank you. So if you multiplied 4 times 24, you'd get 96. So then half of that would be 48 megahertz. So how? What's another way of getting 48 megahertz? You could just multiply 4 times 12. So you could set the multiplier to 12 and the output divider to 1. So either way would work. Now, the SPI, now how fast should you run the PB bus? This gets complicated because one of the things that's going to come off the PB bus is the SPI clock. And you can't set the SPI divider to arbitrary integers. You can set it to 2, 4, and maybe 8 and a couple of other values, but you cannot set it to 3, it turns out. Tried that. And you're going to want to run the SPI clock as fast as possible, consistent with the limitations on the whiteboard. The whiteboard has very limited bandwidth because of the capacitance between the pins on the whiteboard, which amount to a few picofarads. So, I think people were running it for lab 2 at what frequency? 15, 20? 15? Works reliably at 15. Hope you're using 20? Some people were using 20. How fast? 16? Oh, interesting. 16. 20. And it ran okay at 20. And I believe it does run okay at 20, but it's not going to run at 30. So if you make this 60 megahertz and run this at 60 and divide by 2, it's not going to work. If you do, it's too fast. If you divide by 4, you'll get 15 megahertz. It would be nice to have 20. Well, all right, so there's going to be some sort of complicated trade-off between the CPU rate and the maximum SPI rate. You could try, you could see how fast the SPI will run. It might, If you built a solder board and avoided the whiteboard, you might be able to get 30 megahertz out of it, although I believe that the DAC is only rated at 20. It might work at 30 anyway, but it's only rated at 20. So you're going to have to do some sort of optimization in PLL space to make this work.
Why is the SPI clock such a big bottleneck for the performance?
Why is the SPI clock? Because everything you do is going to be reading and writing balls on the TFT screen.
If we only run at 15 frames per second, is it?
15 frames per second. The critical question is how many points do you have to draw? Because each point is an SPI transaction. And the more balls you have, the more points you have to draw. Therefore, it'll be a bottleneck in terms of number of balls. Or it could be a bottleneck. So then the question comes down is, how fast can you actually draw a point? And I did some benchmarking on this, and I believe it's around 5 microseconds. So then the question is, draw a point. So the question is, how many points are on a ball? You're doing 1 point, 5 points. Have you thought about it yet? Are you drawing a small disc, or are you just drawing 1 point? Because the more points you draw per ball, the slower it's going to be. So if you have nice, big, fat, diameter, multicolored balls with the 8 ball marked with a stripe, or all in black, and then it's going to be slower than if you have single points. On the other hand, it's a little easier to debug if the balls are bigger, because you can see the colors, and you can, oh yes, when you're testing this thing, when you're testing the collision algorithm, a really good idea is start out with a simple collision system that you understand. Let's say you have 2 balls sitting at rest on the screen, and you fire a ball into them. You can predict what should happen, right? This one should go this way, this one should go this way, and something will happen to this. It might get bounced off in the other direction, but it should be symmetric. Now, if all the balls are 1 point, it's really hard to tell which ball is which if they're all white. So you might make 1 red, 1 green, and 1 blue, so you can track them before and after collision. This is just for testing. Think up a couple of simple arrangements for which you can predict the results to test the collision algorithm. This is like step 1 for the animation stuff. What else on Lab 3? Let's see. No questions on Lab 3? Let's just talk a little bit about plagiarism. Final project is coming up. And again, I don't particularly want to talk about you plagiarizing other people's projects, because you all know the rules on that. What surprises me is how often our students' stuff gets stolen. And I want to talk a little bit, how do you protect yourself against that? Now we're not talking about don't lie, cheat, and steal. I mean, we all know that. What we're talking about here is, how do you keep yourself from getting ripped off? How do you, we all live by putting everything we own up, for barf it onto the internet for public consumption. That's how academics live, is by publishing stuff. Put up all the course materials. How do I protect myself? Well, I pretty much open source it and say, all right, people want to copy it, so what? You may have a different view. For instance, it would probably annoy you if somebody took your 5-week project and then published it in the IEEE when you could have done it. And that happened. I don't know if you've looked at this yet. This happened in 2009 where a project by 2 of our students, Arjun and Arjun, was copied into an IEEE paper by 3 researchers at Mechatronics Engineering Institute. And this guy is an assistant professor. So this rightly annoyed the Arjuns. And I used this for another short talk, so you all know what IEEE is, or what ECE 4760 is here. So I won't say anything about this. But what they built was an autonomous parallel parking car. So it has distance sensors front, back, and one side. It'll drive up beside an empty spot. It'll back into the spot. Cool. And there was a video, but I think I've lost that. I'm not going to bother with that right now. And so early in 2009, a friend of these students reads the IEEE article, which is in a bound volume, right, and forwards it to the students. Students write to me on March 19th, please find attached paper published, blah, 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 blah. Write-up uses exactly the same words. IEEE conference. Is this allowed? No. So I was in the middle of writing a lecture or something, so I wrote back this real short 3-liner. And before I could get back to them, even, by the next day, they had had figured out how to submit a plagiarism report to the IEEE and done it. Okay? But just for grins, I put up here the abstracts. The red are the differences between them. The students, Bao Ping Zhao, right? Amazing. Amazing. The data images, they are the images of the same down to the JPEG artifacts. He didn't even bother to redraw it. The first paragraph of the results. Speed wasn't a big issue for us. So they're identical. So the students, first of all, contacted Zhao. It's come to my attention that you published a paper on parallel parking algorithm recently. It turns out your article is an almost exact copy of the work I did 1.5 years ago. Is this just coincidence? He's so nice. Of course it's not coincidence. But look, get the response. I sincerely apologize, blah, 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 blah. I'm an electronic lover. I found your work on the web very interesting, so I began to learn your work. And let's see. Oh, published without taking your work as a reference, though its main idea learned from your work. Learned from the work, it was just copied, right? So he's putting the best face he could possibly put on it, but it's BS. So the students send a complaint to the IEEE, and So I ask you to take the paper off the IEEE conference publications and provide Cornell University with written apology. And they actually did this. But there's a few steps. The IEEE plagiarism guidelines say that the amount or quality does not play a role in defining plagiarism, but the severity of the action that is taken against the person is determined by the quantity of copied material. It also says that it is not sufficient to just say, we use the material from this paper. If you copy a big chunk of it without quoting it, it's plagiarism. And the scenarios are uncredited verbatim copying of a full paper. Yes, that's them. Uncredited verbatim copying of a large portion down to very minor things. And what happened was, committee found, they give themselves 90 days to respond, which is forever when you're waiting for one of these things. Because all the time you're looking at the, at Google. Anyways, automatic parking of copied major portions of your original paper, blah, blah, blah. I found that misconduct fell into the category of level 1 plagiarism as defined in the section we saw earlier. And the result was, well, all right, here's the guidelines for what should happen. And what did happen was that the committee banned the authors from the IEEE for 5 years. And every single reference on the IEEE page to his articles was replaced by links to our web page. Now, the IEEE did an interesting thing here. After the students found the first one, the IEEE proactively scanned the rest of his papers and found 6 more. And then I found another one. And the last one I found was the 8th one he'd copied that I know of. But by this time he'd gotten a little smarter and was paraphrasing the words such that you couldn't detect it with a real simple text search. But the one he copied and paraphrased was Ethernet fingerprint capturing on authenticating system. So I look at this thing, the words are all different. The thumbprint is my student's thumbprint. All right, duh, right? So I send this into the IEEE and they banned that one too. Yikes. So if you go to Google now, the entire first page of Google, if you Google Baoping Zhao, the entire first page of Google is all retractions from the IEEE. Any questions on this? So how could you protect yourself? 1, get it into print first. If you think there's a publication possibility on this stuff, don't mess around. Submit it to a conference, submit it to a journal, submit it to a magazine. Get it in print. Alternatively, if you think there's an intellectual property aspect that you want to protect, let's say you're going to try for a patent, don't put it on the web. Now, there's an advantage to putting stuff on the web because it's advertisement for yourself, and we all live by advertisement to some extent. And there's another advantage of putting it on the web where I can find it, because if I ever have to write a recommendation for you, that means I can remember something about you by reading, 5 years from now, I can look at this and say, oh, I remember that. On the other hand, not putting it on the web gives you some protection against plagiarism. So it's not an easy thing to decide what to do. Any questions? Yes?
What benefit do you get by publishing to actually?
Oh, it looks great on the resume. I mean, let's say, particularly if you want to go to graduate school. But no matter what you end up doing, having stuff in print looks good on your resume. Small advertisement I'm going to insert here. In the spring, I teach a writing course where you take the final project report from this course, try and convert it into a magazine or journal article and get it published. Talk about that later. Another plagiarism event happened in 2015. This is I haven't really done much with this, so it's a little bit cruder. But I ran across, there was an MEng project, acceleration of stochastic algorithm on FPGA system, done by one of my students. And I found an exact copy of his MEng report published in a journal by Sheila Rokai-Mary. And it was in a pay-to-play journal. That is to say, it is a journal that you send them anything and 1,500 rupees and it's published. There's a pretty funny story about the extreme of this. A guy from the US sent them a paper whose entire text content, including names, title, and everything else in the paper was, take me off your effing mail list. And they published it. So not only is it not reviewed, it's not even read, it's not even looked at by a human being. Anyway, so I get this message back, sorry, I bought this project from one of the project centers. So, not only she bought it. And so I told her to take it down. The journal doesn't. So I had to explain to her how to take something off of a journal, which she did. And she'd also put it up on a bunch of SlideShare sites. There's sort of academic SlideShare sites, and then lost the password for it, so she couldn't take them down. So if you Google her name, you'll find a bunch of our projects and a bunch of completely unrelated things. What gets me is she's publishing on wind turbine design, microcontroller use, and piston engines. Nobody does all of that. Respiration monitor you published is copied from my students. Yeah, I saw the mail. I actually bought everything from the same project center and requested my students also do it. So she's a teacher and she's telling her students to buy the projects. This is shocking. I mean, that's when my brain seg-faulted. Here, most every student will buy projects from Project Center. Only one or two will do their own. And I didn't write it down, but I wrote her back saying, I'm not taking students from your school anymore for MEng.
What is the Project Center? Is it like a website?
It's a website where you buy stuff and put it in journals. You buy. In fact, there's a number of these that are around, including ones where you can buy the whole circuit pre-built and the paper written. What's the point? Who thinks these things up? It's just mind-boggling. So the bottom line is, get it out there yourself before somebody does. I think there could be a business opportunity here. Let's say you have a subscription service that scans databases for references to your work that are not from you. And the main problem here is not technical. The main problem is trying to get permission from Springer and IEEE and every other database with a paywall to search their databases. But if you could do that, I'd pay $20 a month to have somebody search for plagiarism on my stuff. I think most people at Cornell would. So you need a couple engineers and a ton of lawyers. Think about this stuff. Think about how you feel if somebody's going to steal your stuff. It's not fun. Any questions? Some of this is just shockingly blatant. Let's see if we do a BAOPINGXAIO. Oh, I misspelled that. It got it anyway. Student, this is my page. Human capturing. Let's see. Notice of violation. Automatic card. This is the original one. Violation of IEEE projects. And it turns out that if you request full text, you get bounced to our site. Yes.
You can actually look up the get me off your fucking mail list, and it shows the paper, and it has graphs and everything. It's amazing. It has a state machine. It has like a state machine. Like
A state machine. Yeah, perfect. It's just amazingly blatant. Publications authored by Baoping Zhao, PubFacts. Let's take a look at that. Slowly it loads. Where's that one coming from? So, any lingering questions about Lab 3? What did you do? Did you look up the paper?
yeah, the FSM I find quite
It's got like a wiggly line. Like,
I can't in all good faith put this up in front of the class. But it is a work of art. Okay, lab will be open this afternoon, obviously, and then Monday morning and Tuesday morning from 9 to noon approximately. Actually, 9 to 1 on Tuesday. Okay.
the whole